You're now at the last calculation you need to do to evaluate your statistically significant result, and this is calculating the confidence interval for the one-sample t-test. This is very similar to calculating the confidence interval for the one-sample z-test with some obvious modifications. Of course, you have your mean of the current sample, that's 478. This is the standard error of the mean that you previously calculated, which is 1.87, and you need your t critical value, the critical value of 95%, which we determined to be 2.00, in order to get your 95% confidence interval. And so the lower limit is calculated as you would expect by taking first the mean value and subtracting from that the t critical value, the t 95% value, times standard error of the mean, right? And on this side we're going to do 478 plus 2.00 times standard error of the mean for this formula. Good. All right, let's get our calculator here. Of course, order of operations, you always do the multiplication first. 2 times 1.87 equals 3.74. And that value will be the same for both equations. You're just going to do a slightly different thing with that value. Here you subtract that value from 478. Here you add the value to 478. So let's do this. 478 minus 3.74 gives you 474.26. And when you add that value, 478 plus 374 equals 481.74. This is your 95% confidence interval, all right? And we might write that 95% CI equals 474.26 to 481.74. Now, when we were discussing the one-sample z-test, we talked about the meaning of this confidence interval. And what you want to do, because your mean value exceeded the value, in other words, is greater than the value of the population that you were comparing it to, which was 474, right? The mean population value in this example is 474. What this is saying is that at the lowest end of this new estimated distribution of means, you might come this close to the population mean. And in interpreting your result, the known population mean of 474, right? So this doesn't exceed that. This lower limit does not exceed this by very much. So while the range of these numbers is fairly tight, so we would say, well, this estimate is pretty precise. However, it comes pretty close to this value from the known mean population, and you have to consider from a practical point of view how to interpret this result, given that it comes that close to the population mean. So go back to your book and read some of the comments about this now that you've seen how it's calculated, so you're clear on what to do with these numbers.